Hi, it's Kerem Topçuoğlu with student number 01018020. I'm a civil engineering student at Istanbul Technical University, and I want to show something about Hardy-Cross method, uh, how to uh, how to apply the Hardy-Cross method to the Excel file. We have one question for this application in the water supply severe systems lecture. This is recitation 6, and this is the first question. Let me look at the question before the Excel file that I created. Uh, the question wants discharge values for each pipe, and we say use the Hardy-Cross method, and the R values is given. Um as using Hardy-Cross method, we should make some assumption about the discharge values firstly, and after that, after the assumption, we make some iteration steps and uh, try to getting close to the real discharge value. And in this system, we have two loops, ABC and BCDE. We made another assumption, like for the loops, like we say that the clockwise direction in our loops is positive. So if the flow is reverse according to our clockwise direction assumption, we say that the sign is minus, and we calculate the RQQ value with minus sign. So let we after the uh, questions after the questions description, let's look our Excel file. Before that, we made the assumption like this. Let I describe it. The 100 liter per second discharge value coming from the system outside, and I don't say always liter per second, the 100 coming from here, and we say that let the, as an engineer by the way, because if you make a far far assumption to the real discharge value, you have to make really you have to make the iteration for hours to hours. So you should use your engineering experience and make the assumption closer. So we made the assumption like this. We say that the 100 come from A, and in AB pipe, we say that the discharge separated like 60 and 40, 60 AB and 40 AC, and after that, the water coming when the water comes to the B point, it's separated like uh, 10 for BC and 50 for BD. 10, let me look AB 60. Sorry, 10 for BC, 60 minus 10 is 50 for BD from here. And after that, 50 coming from here and 25 comes out to the go out to the system, and so 50 coming from here, the 25 is here, so DE pipe have 25 discharge value, 25 liter per second discharge value. The 25 coming from here, and the from the E point, the 50 going out from the system. It's meaning that CE equals to 25, because 25 plus 25 is equals to 50, as we see, as shown in the Excel file that I created. So After the explanation of q values, q assumption values, iteration number is 0 because we made firstly assumption, and after that we're gonna make iteration. The signs I describe it, and our values is given, pipe no and pipe name you should you would make as you want, so it's not important. And the RQQ values, the RQQ values is R times Q square with multiplied with the +1 because of the sign, like this. And after we don't have a sign in to RQ values, the RQ values is like this. And after that, for first loop, we after the calculation made, we calculate like q, like this value as minus cumulative summation of RQQ over cumulative summation of 2RQ, and we find the Q value like 1.82. And this Q value is meaning that the assumption, the Q value is meaning that actually if the Q value is lesser than 1, it's meaning that we have really close discharge values to our real discharge value for pipes. So this 2 is good, is not this assumption is not bad. So we have, it's meaning that we have like 2 steps for iteration to do coming closer to the real discharge values. After defining 1.82, we add this value to the BC. Why BC? Because BC is the common pipe for 2 loops, for our first loop and our second loop. This BC is common. So we say the BC is 10, and we say for second loop BC is not 10, BC is 10 plus because sign is plus, 10 plus Q value. The other values is same as our assumption. So after same calculations, we found the Q values. This Q value is really big, so it's meaning that we have to make some iteration. After the same calculations, as adding the Q values, all of the first assumpted values, we find new Q's like this. As we see, the Q values is really lesser than first Q value. After our other iterations, our Q values becoming lesser than the others. So that's the meaning. That's the meaning of iteration, by the way. So I think we should stop at the third iteration because both of the Q values is lesser than 1, and with these Q values we found the discharge like for first pipe 65 liter per second. We assumed like 60, but the real value is, this is not real value by the way, but it's really close to the real value. This is it's meaning that our assumption is really good because the difference is 5. Here the difference is 1.5 approximately, and here the difference is 7. It's not good assumption. If we say it's 20, the iteration gonna complete at the second step, but it's not important. So as a conclusion, after the first question with Hardy-Cross method iteration, we found the new Q values like this. Thank you for watching.